Okay, so the next definition in chromatography is high equivalent to theoretical plates, or abbreviated as HETP, or simplest one is H. This H is used to compare the column efficiency of different length. So imagine a HPLC column, we have 5 centimeter, 10 centimeter, 15 and 25. So the longer the length of the column, okay, having the same dimension between each other, the H will be higher. Okay, if the N is the same, we don't want higher H. Okay, we want low H. Okay, just now we want high N, but we don't want high H. We want low H. The lower the H is better. So means that the longer the column will give you less efficiency. Okay, so resolution is the degree of separation of two components leaving the column, or simply says that the resolution between two peaks. Okay, this is not a good drawing, but you can see that they are resolved. Okay, we want something like this, we don't want something like this. Okay, so this is not resolved altogether. So how do we know in terms of numerical value whether the resolution is acceptable? So you can calculate by using this equation. So you see that this is the retention time for first, and then the second one, and then you can calculate by using the peak width of each peak. For example, over here, after we calculate, because our resolution is unitless, okay, you can use anything. You can use time, you can use centimeter if you use your ruler uh, um, to measure the length. And how do we know the numerical value is okay or not? Instead, the resolution must be 1.5 and above. So this 1.5 shows complete resolution. Okay, so 2.1 is okay lah. Okay, so what if you have a resolution of around 1.0? Is this acceptable? It is not acceptable. It will show your chromatogram something like this. Okay, just like that. Okay, we want something like this, completely resolved. Okay, so but what if you have a resolution of maybe 5? Do we want this? It depends on your application. If let's say the total separation time is not that long, 5 is okay. But if your total separation time is long and you have like tens of analytes, resolution of 5 is not good. Means that the peak is going to be like this, 1, and then the second one will be here. So this kind of resolution will take up the time. Okay, remember we want uh, the optimum time for it. So if you ask me, do we want 5 or 2.1, I would follow 2.1. Okay, because I want to save time. So and then we have the separation factor or selectivity factor definition. This alpha, okay, so this is the measure of how good the column is as to retain an analyte as compared to the void volume. Okay, means that how far it is from the first void volume lah. So alpha usually lies on the value of 0.0 till 1.5. So if you have 1.4 over here, it shows that the 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 distance between A and B from the void volume is just nice. Okay, it's not that far, it's not that close.